Okay, these are the problems I asked the student do at the beginning of this class, and then we will go over this right now. I am not saying that your tests later on will look like exactly like this, no, but from my test, question number 10, for example, is a very common question that I asked. Number 12 also is very common, okay? And then number 13, recently I asked that a lot, okay? And then number 14, also something I asked recently a lot now, but I have no plan to change the structure yet, at least not in my test one. Okay, it's more about, I would like to know if you can follow my instruction and work on the procedure for the frequency distribution part, which we don't cover today. Okay, we have done that a couple of times in the past lectures, and today we go over the probability part in test one. Okay, so it's kind of like, don't expect too much. Don't expect that it will be exactly like this, of course, but do expect that it will be quite similar. Okay, I will go over this now. Number 10, a group chosen for medical study in the college contains 70 participants with 24 smokers among them. There are 36 female participants and 5 of them smoke. Part A, construct Venn diagram, which you always start with a rectangle. Okay, you start with a rectangle. Now, so prepare at least a straight edge. It doesn't have to be a ruler. I think a student ID will be good to make it straight. Okay, and I don't need you to make it perfect, but of course at the same time, I don't expect you to start the Venn diagram with something looks like this. No, this is not a rectangle. You see? Okay, that's not a rectangle. It looks, I know you try to make it a rectangle, but it's not. Okay, now I use a software that I can make the rectangle really fast. That's my benefit, but make it at least looks like a rectangle. Okay, and then I will have a group of smoker. And another group which they identify as female. Now from here we see the number of people in the group is 70. The number of smoker, do not use S. Smokers, if you make it S, then it looks like the sample space notation. Okay, so avoid that. The number of smokers is 24. The number of female participant is 36, and the number of female and smoker is 5. Okay, now then from those informations, we see that the female and smoker is 5 here. Okay, smokers a total of 24, so 19 of them smoker and not female, right? Okay, outside of female, but smoke. On the other hand, there are 36 female, 5 of them smoke, means 31 not smoking. Now, so far, how many people here? 55, but we need 70 people, so 15 of them outside, is it right? Okay, now that's for the Venn diagram. When you study for from my old test, you can use this rule. Okay, you see, like this 5 here, that's the number of points for part A. This second, the 3 here is the number of points for part B. And the last 3 here is the number of points for part C. Okay, now use those number of points when you study. the number of points in the test is also representing the number of the amount of time, the number of minutes you need to solve the problem. Okay. In fact, when you study at home, subtract it by 1. So in other words, for example, this 3 minutes here, these 3 points for this. Okay. In your test, that means 3 minutes. Okay. But when you study at home, try to do it under 2 minutes. Okay. Now I'm not saying that if it is 3, then you should be able to do it in 2 minutes. No, it is possible that you can do it actually in 30 seconds, you know, but I assume that if you kind of like get slowed down a little bit, then it should take you less than 2 minutes. Okay, but if you are very well experienced, then 1 minute is reasonable. Okay, yeah, that's how you will study from my old test. When is your test, by the way? Let me just remind you. Test 1 will be 2 weeks from now. Okay, it's 2 weeks from now, and I want you to get ready because implicitly you have at least 2 weekends to study. Now, do not ever think that you just need to study last minute because you are smart. No, that's not a smart point of view to start with. Okay, doing things last minute is not a smart thing to do. Okay, you cannot say I'm smart, therefore I do something not smart. That's contradictory in the same sentence, right? Okay, so okay, let's start with part B then. In part B, in an experiment of selecting a participant from that group, write the notation and compute the probability of selecting a female smoker. So the notation is probability of female and smoker. Like female smoker, female and smoker. The number of female and smoker is 5 over 70. Either you reduce it or you change it to decimal. Now let me teach you how to reduce a fraction on your calculator. Now I assume you have TI-84 already. TI-84 and TI-83 can do the same thing. Let me see. Okay. This is your, let's say this is your TI-84. Okay. Now, you want, let's say you want to reduce 5 over 70. So 5 divided by 70. I'm sorry. Okay. Now, and then go to math. The very first one. This means convert to fraction. This means convert to fraction. It's already a fraction. It's already a fraction. You know, but this will reduce it. Do you see that? And you know that 5 and 70 have common factor 5, so it will reduce by 5, right? Now the thing is, what happens if the simplification takes a lot more process instead of spending your time with that kind of algebra, actually arithmetic, just use your TI-84 then. Okay, so you can do it this way. Let me repeat. Let's say if you want to reduce 28 over 144. Let's say you want to reduce that. Okay, so you type that and then you go to math. Okay, the math part, there's a fraction there. Okay, convert to fraction and then enter. Okay, now in the past I did it this way and it's okay. So what I did was 28 divided by 144. Then I give myself decimals and then I go to math, convert that to fraction. You see, so I get it to decimal first and then from decimal convert to fraction. But it's actually not necessary to go to decimal first. You can just go ahead right away. Okay, that's for reducing fraction. Let me compute at the same time then what will that be in decimal. 0.07143. 0.07143. This is equals to 0.07143. You round to 5 decimal places. And don't forget, you need to have that leading zero. Okay, you need to get that leading zero. Now, if you want to leave it in decimal, then don't forget the leading zeros, 5 decimal places. Now, here I didn't say specifically I need you to make it into decimal. Okay, so if you want to leave it in fractions, fine, but you need to leave it in simplified fraction. Okay, so either way, you may need to use calculator. Okay, part C. In the experiment of selecting a participant from that group at random, write the notation and compute the probability of selecting either a male participant or a non-smoker. Now, notation-wise, when we say male participant, it's not female, outside of female. So the notation is supposed to be like this. Okay, but Thomas, not female is male. Male is not female. Should I write it that way? Can I just write male? Technically, no, because in our Venn diagram, we only see smoker and female. So male should be interpreted as outside of female. That's how we will see it. Okay, so continue, or non-smoker. So I write smoker and then not. You see what I mean? Now then, not female refers to this guy and this guy, right? So that's 15 plus 19. It's an OR, don't forget, it's an OR. So once it satisfies one of them, you count it in if it is an OR. Or non-smoker, that's 31 and 15, but 15 already counted, so 31 over the total of 70. What is this? This is 50, 65. Over 70, that is equals to 13 over 14. Okay, now if you look at my old test, not only one, never study from only one test. If I were you, I would study from 3 previous tests. Okay, and first try to do them right. Okay, and then after that, then you focus on how to do them fast. Okay, but do not focus too much on your time at the beginning. At the end, you need to have the correctness and the structure. You need to be able to show your work nicely, neatly, so it's organization. Okay, yeah, but then also focus on your time. Okay, with some practice, you will see you have enough time. Yeah, if you don't practice enough, then you should be the one complaining at the end that you don't have enough time. Especially after you're done, you need to take the pictures or you need to scan it, right? Convert them to PDF and then upload it to Canvas. Okay, number 12. What is the total number of elements here? And it's equals to, anybody can help me?
I got 64. Wait, yes.
10, 20, 30, 47, 49. That's right, that's 64. Okay, so the ones in B will be, the way I show the work is the one in B, 6 plus 4 plus 7 plus 3 over 64. That's 20 over 64. Now, however, don't forget, it says here, leave your answer in decimal. Okay. Now, plenty of students, when they see this kind of question, they don't really read the question in full, such that they left their answer in decimal, in fraction. You know, I want you to make it in decimal because I write it in decimal there. So some of my problems, I say leave your answer in fraction, simplified fraction. Some questions I say leave your answer in decimal. Okay. So please read the question though. I mean, that's a very simple things to do, but you still need to do it, right? Okay, 20 over 64 is 0.3125. Is it okay, everybody, so far? Do you see any curveball so far? Like things that, you know, Thomas, you just want to, you just want to make it hard. If I want to make it hard, I will not teach you at all, but just show you in the test. You know, no, I want you to learn. I want you to learn. So if there's anything hard, let's do it right now. Okay, such that during the test, during the test, I understand most of you, including me actually, when I took the test, there is a built-in anxiety in the test. Okay, but hopefully that anxiety only comes from the fact that we don't know what is coming to us, right? And we have restricted time, not added to, not compounded by a situation where you didn't study enough. Okay, in fact, if you study enough, you should have faith in yourself and in me that I'm not someone who gives you curveball that wreck your B or C. At times, I give you hard question though that you never see. Okay, but not in my test one. Not in my test one. Okay, not in my test one. You may not see the problem here, but you must have seen that similar problem in other tests. Okay, so if you study 2 or 3, let's say 3 tests, then you must have seen all the possible variations for my test 1 for now. Okay, now coming back here, probability of A intersection C. A intersection C refers to these two guys here, right? A intersection C, okay, 2 plus 7. That's 2 plus 7 over 64. That's 9 over 64. 9 over 64. That is 0.140625. But I round it to 5 decimal places. Becomes 3. Okay. Thomas, can I make it 6 decimal places? Yes, you can. But at least 5. At least 5 decimal places. A union B. A union B, either in A or in B. So it refers to those 6 numbers there to add, right? That would be 17 plus 6 plus 7 plus 2 plus 4 plus 3. What is that? Morning 39 over 64, which is 0.60938. Now the third one, probability of A and not B. The one in A's are these. That's the one in A, and the one not B are these. These are the one not B. Okay, now because it is an intersection, it must satisfy both of the requirement. It refers to only these 2. Okay, now we can also see it this way. We can also see it this way. Okay, it should be in A, so you should you circle the ones in A. These are the ones in A, and outside of B. Now from these, see which ones are outside of B. This guy and this guy. You see? So it's 17 plus 2. That's 17 plus 2 over 64 equals to 19 over 64. 19 over 64, that's 0.29688. Now, how about B union not C. It's a union, so once it satisfies one of the requirements, you can count it in. This is the one in B and the one outside of C. These are the one outside of C. Okay, now remember it's an OR, so once you circle it at least once, you count it in. So I will get the one in B, 6 plus 4 plus 7 plus 3 plus the one not in C's, not in C are 10 and 17. Over 64, that is 10, 20, 30, 47 over 64. Then I go to my calculator. That's 0.73438. Any questions so far? Okay, I go on. Probability of not B and not C. It's out of 64. Not B are these. These are not B's. Now of these not B, which are not C's. It's an N, right? N not C. So this is not C. This is not C. So that would be 10 plus 17. That's 27 over 64. That's 0.4218. Lastly, not A or not C. Not A or not C. Okay, but it's an OR, so once you count it, once it falls into one of the requirements, then you count it in. Not A's are 10 plus 15 plus 3 plus 4, that's not A, plus not C. Not C are 10, but I counted already, 17 and 6 and 4, but I counted 4 already. Okay, and then I put them together, 10, 20, 30, 55 over 64. Now, somebody asked me this question, Thomas, can I just get the decimal right away? Do I need to show the word for this? If I were you, I will. If I were you, I will. I will show the work, okay? 8, 5, 9, 3, 7, 5. Because that's if 6 decimal places. It's okay if you write 7, 5, but I want to round it to 5 decimal places. Here's the thing. Imagine me as an instructor. If you don't write anything, but you just write this. Okay? In the past, I think I just let it go. But what happened was this. What actually happened was the person actually didn't write anything and didn't even write that one. That person wrote this. 0.73437. Okay, so that person remembered 5 decimal places, but didn't realize that he or she is supposed to do rounding to 5 decimal places. Okay, and because there's no work at all, that person didn't show this thing, I have to mark it wrong. Okay, because it's wrong. I have no reason to give you any points. But Thomas, you know what I mean? No, I have to judge you, I have to grade you based on what you write, not based on what I think you want to write. I'm not a mind reader. I'm not trained to be a mind reader, and I don't want to be a mind reader. Okay? Some people think, Thomas, don't you think it's good if you can read people's mind? Well, it's good, but I don't want people to hold it as if I'm required to read somebody's mind. No. Okay, I don't even try now to read my wife's mind. No. Okay, say what you mean what you say. Okay, so now I say this because I need you to learn to express what you have in your mind in systematic, structured, understandable way. Trust me, trust me. Whoever can articulate what he or she has in their mind better, okay, they will be viewed as somebody makes more sense. Okay. When we try to argue in public, especially, not argue in a negative way. Let's say I have my opinion, you have your opinion, right? But whose opinion will prevail in public? Those who can actually explain why you have such opinion in structured way. Okay. One thing I hate the most, and I also believe a lot of you hate the most, is when somebody told you, you just need to do this. Okay, you just need to do this. Don't ask why, right? You see, if somebody starts telling you doing things without telling you the reason behind it, that person just basically treat you as a kid. And no, we all refuse to be to be treated as a kid, as a children, as if we cannot think on our own, right? You're in college already. Okay, so I do expect you to wear your thinking cap. Okay, now that's for number 12. Let's go on to the next question. Number 13. The following contingency table describes the distribution of smoking status of 150 participants. I remember, I think at that time, I did ask the class at that time, hey, you know what, for your test one, what kind of topic you want me to talk more about? And they say, oh, you know what, let's talk about smoking, you know. Okay, some people at that time want me to talk about politics, and of course the rest of the class say, no, we don't want politics. And I don't think I want to go to that direction too. Okay, now then, even though sometimes I bring it up in my test, but I try to make it off election, off election semester where we don't have election. Okay, first find the total for each row and column. Let me do so. This is 37, this is 45, this is 58, which if I add them, what do I get? 95, 140. Oh, something not right here, Thomas. I know. So that's 49. This is 48. And this one is 21. That's 43. So the total is 140, not 150. Did you do this yet? Okay, if you did it, then you will notice that from the total, we get 140, which is not 150 as said in the percentage of that. Now then, in this situation, which do you believe? Which will you take? Now, you're supposed to take 140, okay? Not 150. Why? I claim 150 here, but when I show you the data, it's only 140. So which one do you believe? Somebody's opinion that I told you is 150, or from the empirical data, you have 140. Always believe empirical data, regardless you like it or not. Okay? I heard this a lot. Facts don't care about your feeling. You know, I would like to tell those people, well, sometimes don't tell the fact because you hurt my feeling. Anyway, we come back here. But in this case, because there's a contradiction, which one will we take? We take the one coming from empirical data. Okay? Then, In this question, we will do write the notation and find the probability of selecting part A, non-smoker. And here I specifically say non-smoker means currently not smoker. Okay, means if they were formerly smoker, you don't count it. Okay, now then, how many people actually not smoking, not currently smoking? That's 37 plus 58, is right? Over 140. That is 95 over 140. Then you use your calculator. Then you use your calculator to reduce it. Let me grab my calculator. 95 divided by 140. Actually, you can see it. You just reduce by 5, right? You reduce both by 5. But you know what? I use my calculator. If I reduce by 5, I get 19 over 28. 19 over 28. Thomas, why earlier you change it to decimal and now you change it to fraction? Well, because I said it here, leave your answer in simplified fraction. Okay, because I say it there. Okay, Thomas, what happens if you don't say anything? Then it's up to you. Either you make it in simplified fraction or in decimal. Okay, now keep in mind, I didn't say you can leave it in fraction only. I say you should leave it in simplified fraction or decimal. Okay, under very, very rare case, I will tell you don't need to reduce it. Don't need to simplify your fraction. But if you have a choice, you can do it, then do so. Okay, part B, probability of selecting a former smoker. So former smoker with a bachelor degree. With a bachelor degree means that person also have bachelor. Former smoker and bachelor, there are 22 of them, 22 over 140, reduced by 2, 11 over 70. That's the simplest possible. Part C, a smoker or an associate. Smoker or associate. Smoker or associate. Now, this one is a bit hard. Smoker refers to the current one. There are 45 of them. Associate refers to 48 of them. But notice that 21 of them double counted. Right? 21 of them double counted. Okay. So if you want to add 45 by 48, make sure you subtract by 21. 45, that's for the current smoker, plus 48, that's the associates, minus 21 people double counted in both earlier. So this will be equal to, let's see, what's that? 45 plus 48 minus 21. That's 72. No. Sorry, I write it wrong here. It's not 70. It's 140. I was like, what happened? Yeah, because I have 72 over 140. If 72 over 70, something must be wrong. Remember that? Right? Okay. Now here, then I reduce by what? I think I can only reduce by 4. 36, 18. 18 over 35. Part D, let me erase this first, not to confuse me. Part D, probability of a high school graduate, but never smoke. Never smoke. Do not use never smoke this way. Do not use never smoke this way. No. Because this can also mean, according to our context here, this also mean not currently smoking. But not currently smoking, you see in part A, not currently, non-smoker, not currently smoking. Okay, it refers to never and former smokers. Okay, so do not use never smoke using this notation. No, don't do that. Don't do that. In this context, especially in this context, because we already assign smoke as in terms of currently smoking. Okay, so high school and never smoke. So it's 14, is that right? That's 14 over 140. That's 1 over 10. Finally, part E, probability of a former smoker without bachelor, so outside of bachelor. Former smoker, that's former smoker without bachelor. Only these two. Right, those are former smoker without bachelor degree. So that is 20 plus 16 over 140. That's 36 over 140. Reduced by 4, that's 9 over 35. Again, you can just use your calculator to reduce that for you. Okay, let me go on. I copy paste the table above earlier because the page was not big enough to cover. But let's see. In this part here, we go on with part F. If two participants, they have to be different then because there are two participants selected from the group, find the probability. You don't need the notation. You don't need the notation. Okay, if you put the notation, of course, it's fine. And leave your answer in decimal. Okay, we need part A, the participants without associate degree. So the probability without associate degree, not associate and not associate. Okay, you know some people get associate bachelor without associate degree. Okay, so you should not exclude the one is bachelor's. Now let's see how many people have bachelor. Let me just cheat from up there. 48, 43. So this is 40, 48 or 40? 49 and 43. 49 here, 43. Now the one without associate degree, they are 49 plus 43, that's 92, right? Okay, so the probability that the first one without associate degree means that person either have bachelor or high school. That's 92 over 140 times. Remember, the participants here should be 2 and they have to be different. Therefore, they have to be different. So this will be the second non-associate degree will be 91 over 139. Okay, now then when you use your calculator, type it all at once. So 92 over 140 times 91 over 139. Why? If you do one fraction at a time, then you are forced to do rounding error times another number with rounding error. You end up with compounded rounding error. Now here, you just do it all at once. You get 0.43022. 0.43022. Supposed to be 215, right? 2158. Okay, but because I round to 5 decimal places, it's 22. Okay, last one. At least one never smoke. Probability at least one never smoke. But that's it. That means one minus, that's the complement of none of them never smoke. Both never smoke. None of them never smoke. So one minus. Now, when we say none of them never smoke, mean either they are currently smoker or former smokers, which implies this is 45 here, and this is 58. Okay, so never, the one not never smoke will be 103 over 140 times 102 over 139. There should be two of them, right? Don't forget, two participants. So that would be 1 minus, let's grab my calculator. That's 103 divided by 140 times 102 over 139. I get 53988, 0.53988. Now subtract from 1, I should get 0.4602, I'm sorry, 1, 2. Okay. Now lastly, number 40, and number 14. Probability of A, probability of B given, probability of the union is given. We need to find probability of the intersection. So what relates these four quantities here? Inclusion, exclusion formula. Now, when you work on that, write down the formula first. Write down the formula first. Okay, I do penalize points if you use a formula without writing it down first. I penalize like half point or 1 point. Well, anyway, 0.8 here equals to 0.57 plus 0.64 minus the probability of the intersection. 0.8 equals to, this is 1.21 minus probability of B intersection. So probability of B intersection equals to 1.21 minus 0.8. I get probability of B intersection to be 0.41. Okay, now that's the probability part from your test 1 as a review. And I strongly encourage you to start studying for your test 1 from my old test 1. Okay, now let me go on with the next section. The things I will do next is, I don't remember the section. I think it's 5.3. Let's see. It's the last part. Yeah, we did 5.1 and 5.2 last week. So yeah, and I was done with that. So go back here. I will do 5.3. Is it 4.3 or 5.3? Well, I'm kind of like a bit confused. Is it 5 here or 4? It should be chapter 4, right? Why I say 5? See chapter 5? It's chapter 4, not chapter 5. So I actually make a mistake here. Should be 4142. Okay, not 5152. I have this confusion because my YSLA college class, their probability actually start in chapter 5. Your probability start in chapter 4. Okay, so I hope you didn't misunderstand me here. It was clearly a typo though, come from my misunderstanding. Yeah, it should be chapter 4, my bad. So it should be chapter 4. Now it's 4.3. 4.3. Yeah, it's 4.3. Okay, 4.3 is on conditional probability. 4.3 on conditional probability. And here's the definition. Definition. Probability of A given B denoted by P parentheses A straight vertical line B is the probability of event A to occur knowing or assuming event B already occurred, also occurs, or occurred. Is it double R or single R? I think single R. I don't teach English anyway. Okay, so let's say, for example, to help us visualizing this, let's say, for example, I have a Venn diagram. Let's say, for example, I have a Venn diagram. I really want to copy paste the one we had earlier. Smoker and female. 5 here. 24 smokers, and then how many female? 15 here. I just needed to grab an example. Okay, now let's see. So suppose we select one element at random. Suppose select one person from that group at random. And what is the probability that person is a smoker? Now, notice that this one is without condition. There's nothing here says that given what. No, it doesn't say that, right? Now, if it's not a condition, it means you select from the whole sample space. Now, the number of smokers are 24. The number of smokers is 24, right? Go for 7. over 7. So that's 24 over 70. I forgot what's that. Okay, now I want to contrast this now with probability of smoker knowing that person is female. Okay, given female. So the notation will be probability of the event we desire given knowing that person is a female. So instead of selecting from the whole Venn diagram, we only select from the group of female. Knowing that person is a female, what is the probability that person is a smoker? Okay. Now, when we work on this type of problem, we start with the denominator. How many female there? Instead of selecting from 70 people, we select from 31 plus 5 females. Right? Now then, of these 36 people, how many of them is a smoker? 5 of them smokers. You see? Okay. Now let's try again. Let's try again. This time, how about probability of selecting a female knowing that person is a smoker? So which group do we select from? Do we select from the group of female or do we select from the group of smokers? The condition is smoker. Female. No, the condition is smoker. That's the condition. So we will select from the group of smoker. That's the condition. Okay. That's the condition. And then later on from there, we see how many of them female. So the group of smokers, there are 24 of them, 19 plus 5. There are 24 smokers. Okay. So with this condition means we select from the group of smoker. Now, of those smokers, how many of them female?
Five.
There are 5 of them. That's right. Hey, you try this. Next one. A bit harder. Okay, I start combining with what's that? Complement. Probability of female knowing that person is a non-smoker. Now then, how many non-smokers? How many non-smoker?
Is it 31 plus 15?
That's correct. That's 31 plus 15. And of these non-smokers, how many of them female? That's right. So this will be 31 over 46. I don't think I can reduce it. Okay, so the condition tells us how many people we deal with to start with. We are not dealing with the whole Venn diagram, the whole group. No, we deal with subgroup. That's why we call that conditional probability. So instead of selecting a female from the whole group, we already know we start from non-smokers. Okay. Now, of course, these numbers that I give you here is not actual numbers, so don't interpret anything from here and apply that to your real life. I will still interpret that here, but not in sense of real life. Okay, not in sense of then in reality this is what you should do. No, because the numbers I have here are fictional. Okay, now what I'm saying is this: suppose we have this situation, we have this group here, and you know that the person in front of you are smokers. Okay, now should you expect more female? If you have this data, and somebody tell you, oh, okay, now I present you the group of smokers. Okay, and you happen to read this this non-smoker, read the name, you cannot really tell if this person male or female, for example, right? Then if you need to do what we call random chance, will we call that person he or she, for example? Okay, now you definitely do not want to refer to a person with an it. Okay, yeah, but when I look at the name, I don't know, then I will first refer, in this situation, I will first refer to that person as she. And of course, maybe at the footnote, I say, I can't really tell if you are male or female. So I'm sorry if I refer to you incorrectly, you know, like that situation, you know, okay. But I hope then once we learn conditional probability, with the actual number you get from real life, then you learn how to make decision. Okay, now I'm not, again, whatever numbers I use in this class, it's hypothetical. Okay, what we want to do is to learn how to interpret those numbers and use that for our benefit. Okay, now then the only thing you need to get from your real life later on is get the actual number, because you already know how to interpret those numbers. Okay, from here also we see something very important, that the probability of smoker given female, as you see in part B, is not necessarily the same. It's not the same to probability of female given smoker. Okay, in general, probability of A given B is not the same to probability of B given A. Is it okay? Now, I'm about to give you a break, but I will give you a break together with some work. I will grab the contingency table from here. Let me grab this contingency table. That's not what I really want. Oh, what am I doing? I already... Oh, no, that's not. I'm sorry. What happened? This is true. Now it's better. Okay, so in our next example here, I would like you to try probability of selecting bachelor. So we will select one person. Select one person. And then the first one, what is the probability that person has a bachelor? Second, the probability that person is has a bachelor knowing that person is currently smoking. Part C, probability of currently smoking, knowing that person have a bachelor. Part D, the probability of that person never smoke, knowing that person don't have a bachelor. Okay, so here I basically want you to apply what you learned from the Venn diagram and apply that to contingency table, and at the same time understand what these notations means. Your break will be 10 minutes plus 5 minutes doing this. It's 10 o'clock. We come back at 10:15. Okay, let's start. Continue from what I had earlier. So that's current is 3045 here. The never one is 37. What else I need? Bachelor. Bachelor is 2143. Okay, so the probability we get a bachelor will be 43 over 140. Now, let me just leave it like this, okay? And you continue with the decimal or with the simplified fraction. Now, what happened here? So you see part A is without condition. Part B is with condition, in which we select from those current smoker only. Okay, so we start with how many current smoker? There are 45. Right, and then of those current smoker, how many of them bachelor? Yeah, 9. Right, 9 bachelors. Of those current smoker, only 9 of them bachelor. Okay, and then from there you reduce or change to decimal. Depends on what I wanted. Okay, part C. Probability of selecting a smoker, a current smoker, knowing that person is a bachelor. So how many bachelor student people with bachelor? 43. Of those 43 people, 9 of them have a bachelor. Okay, last one. Probability of not having a bachelor. So not having bachelor is supposed to be this guy here and this guy here. You see, right? But you can also do 140 minus 43. You see, you can also do 140 minus 43. It happens to be computable that way. Okay, so I will use 140 minus 43. Now, of those not having bachelor, how many of them never smoke? Of those not having bachelor, how many of them never smoke? That will be 14 plus 11. So that's 25 over 97. I think I cannot simplify that, but I may ask you to do it in decimal. Are you okay with this? If not, then we do more from the contingency table. If you're okay, then I go through the 3 circles. The 3 circles is actually my favorite though. Okay, let's move on then. Let me get the 3 circles, but I will make you work again. I'm sorry. Yeah, but really the best way to actually learn is by doing it with your hand. Okay, that's why in math we don't say read your math, we say do your math, right? And that's the reason. By doing it, you connect it to your brain. Go on here. Enlarge it a little bit. Okay, and then let me call this example 3. Example 3. Using that, let's find probability of selecting A given C. Part B, probability of selecting C given B. Part C, probability of selecting B given not A. Again, we select one at random from the group. In part D, the last one, probability of selecting, how about not A given not C. Okay, let me ask you to do this in 1, 2, 3, 4, 5, 6 minutes. Okay, part A, probability of selecting an A knowing that person is in C. So let's see how many people in C, how many elements in C. 2 plus 7 plus 3 plus 15. Now of those 2, 7, 3, 15 elements, how many of them in A? It's 2 and 7. 2 plus 7, so it's 9 out of 27. Oh, that's 1/3. And then part B. What is the probability of selecting an element in C knowing that person is in B? In B is 6 plus 4 plus 7 plus 3, which is 20. Okay, but of those 20 elements, how many in C? That's 7 plus 3. Right, so that's 10. That's 1/2 or 0.5. Am I okay? Part C. Part C, probability of not in A, I'm sorry, probability of in B knowing it's not in A. So let's see how many elements not in A. 10 plus 15 plus 3 plus 4. Outside of A, right? That's how many is there? That's 32. 32 elements. Now of those not in A, how many of them in B? 3 plus 4, 7. Okay, so that's 7 over 32. Now finally, probability of not in A knowing it is not in C. Not in C is 10 plus 17 plus 6 plus 4. That's 37. Of those 37 elements, how many of them not in A? That's 10 and 4. There are 14 elements not in A of those not in C. let me relate this a little bit to how you may use what we learn here to compute the probability of with the election that we have. Okay, the probability with the election that we have. Kind of like if you want to do survey, suppose you are in social science, in political science, in psychology, and you want to anticipate who will be the one winning. Okay, so now, not that I like to talk about politics, though, but in case that you want to see how the media actually present their data, sometimes I have to be honest. Sometimes the way the journalists present the data, they start with empirical number, which is a fact that we can take. However, the way they interpret that is totally wrong. You know, so for example, you can actually do it this way. So for example, those who are Democrat and those who are Republican. Now, if that person is outside Democrat and Republican, then that person is assumed to be independent, right? And then of those, we see how many people actually will vote for one particular candidate. Let's say we talk about Biden here. Okay, there are Democrats who say they will not vote for Biden. There are Republicans who say they will vote for Biden. There are independents who say that they will vote for Biden. Okay, now the thing is, if you are actually, for example, a Democrat, your point of view very likely just Democrat point of view. Okay, especially if we are in California. Especially if we're in California, where most of us actually Democrats, right? Okay, so when we do survey from people around us, we already have that bias. Okay, it's not that we are biased. No, okay, we start from a population that's already biased, in which California is known to be a heavily democratic state. Okay, now, but if you happen to be from Texas, for example, if you happen to be from Texas, then the starting population there tend to be Republican. Okay, so people in Texas, for example, they will think Biden will not win, but that's because they have the bias of their surroundings are mostly Republican. Okay, while we here, because we are heavily democratic state, then we tend to think that Biden gonna win. Now, supposedly you do this kind of survey. If you are in social science, political science, and you want to do prediction who's gonna win, then you're supposed to do this kind of thing here, what I'm about to show you, for all 50 states. Actually, not all 50 states, not necessary. You just need to do this to some swing states, okay? Because, for example, Texas, very likely, not guaranteed though, okay, very likely will be the Republican, go to Republican, okay? And then California very likely goes to Democrats, right? But look at those swing states, which we will study toward the end of this semester, I think week number 10 or week number 11. When we do confidence interval for proportions, okay? But this is what you can do. This is what you can actually do. So for example, we look at one of the swing state, let's say, I think Florida is a swing state right now. Yeah, I'm not sure, Suppose we talk about Florida, right? And then you do some survey, and yeah, the larger the better, but at the same time you can have a very large sample size, but if the sample is biased, then it will not be beneficial. Okay, the reason we enlarge our sample size is so that we get a less biased sample to represent the population, such that we can predict the population better. Okay, but once your sample is biased, regardless the sample size, is useless. Okay, I mean, in other words, you cannot predict from there. Now then, from, let's say you have numbers here, right? So I make up numbers, okay? I make up numbers. Let's say this is 150, this is 200, this is 120, and then this is 300 here, this is 50 here, and then this is 200, maybe 220. Okay, suppose we have this situation. Then what is the probability? What is the probability that, knowing that person is a Democrat, what is the probability that person will vote for Biden, for example? Okay, and then what is the probability if that person is Republican? What is the probability that person will vote for Biden? Realistically, I have to say that this election is way too much heated, such that a lot of hate going among. If you go to Facebook, I mean, my friends actually unfriend each other simply because one of them say I'm for Biden, the other one say for Trump. In fact, I get unfriended also simply because I say I don't want to make my decision in public. You know, this is Thomas, you're a coward. It's like, hey, you know what? It's my fault. You know, because the reason I don't want to make it to say what I vote for, because I don't want my student then think I'm one or the other. You know, okay. I have my own vote, and I don't want my student to follow me simply because I'm their teacher. On the other hand, I also don't want my student to have don't like me simply because their choice happens to be different from mine. You know, it's like, hey, it's politics, okay? Take it aside. Don't mix it with our class, okay? Well, anyway, but suppose you have this situation, then you can do this kind of computation. What is the reason you want to do this kind of computation of probability that if that person is independent, what is the probability that person is for Biden? Now, using these statistics, using these probabilities, then you know which probabilities you need to fight for. And if you do your campaign, what is the best aim? You know, what is the best aim? In other words, think about this. Is independent considered a good source of extra votes, right? Do you want to increase that? You know, I believe it's kind of hard to actually win Republican to vote for Biden to move this here. It's kind of hard. Okay, but is it worth it? Right? Now, suppose this number is already very small. Let me change this to be, let's say, 10 here, right? On the 10. So will you spend, let's say, $1 or $2 million to win these 10 extra votes? You know, then if you have extra money, then you try to fight for this, right? But I think if that were still a lot of people out there, independent, who say that they have not made that decision yet, they will not say they will vote for Biden yet, then you will spend some money on your campaign to focus on this portion of the quote-unquote market, quote-unquote undecided votes, the winnable votes. Okay. Now, of course, this is not only for Biden. You can change this Biden, for example, for Trump. Okay. Or you may want to do another circles here, right? Okay, to see how many people really independent. Because when I say 200 here, it is possible that they already make their decision. Okay? Some of them already make their decision. So if you want to have a more refined view, then you put a circle here, okay, and see how many already decide that they will vote for Trump, for example. Okay, now if they already decide, will you spend money to win their vote? Now, in my opinion, I will not until I already warn those who already don't, who has not make up their mind. You see? Okay. Now I use this election as just illustration. Okay, just the numbers here are all hypothetical, and I hope you don't see me as if I'm campaigning for any one of the candidate. What I know is based on the fact that we are in California, then we are heavily Democrat, right? Okay, so I use Biden, but it doesn't imply that's my opinion. Okay, not at all, not at all. Please don't see it that way. Okay, I don't also imply that I go otherwise, that I go for Trump. No, that's not what I do. Okay, now imagine if then we convert this to your business later on. Convert this to your business. Suppose, what kind of business you want to talk about? Let's say food business. You know, I think food business, homemade food is actually quite flourishing right now on Facebook. Okay, I'm quite active on Facebook, by the way. Now then, you may want to take a look on what kind of food people are interested. Okay, and so you look at your market. Okay, are they more into, for example, grab and go, like it's not like a snack, but the type of food that you can hold in your hand while you drive, like burger, tacos, nachos, burritos. Okay, some Indonesian food also like that. Okay, I don't think steak or something with soup will be considered that type. You know. Now, so for example, maybe I call that snack type. Snack type. Okay, and then another one is the one that you need to eat on the table, right? You cannot just hold it. Okay, the meal type. Okay, and then do research with your market of those people who are working, okay, and those who are students and work, maybe, right? Okay, and take a look on what kind of market you want to actually go into. Okay, now if you are, for example, to those who are not working from home, okay, not working from home, then there's a chance this will not be a good idea. This is not working from home. Go to office, let's say. Okay, I somehow believe if they go to office, they will not be able to go out and go to a cafe and buy some meal. They tend to actually bring it from home. But once they go home, there's a chance they don't really have time to take care their lunch box. Okay, so very likely they would like somebody to deliver it to them to their office. So think about that, you know. Okay, get ideas from doing little survey. You can do this on your Facebook maybe, and then get some idea. Okay, I have seen people on Facebook, families, not only one family, where their husband originally sent home and end up working from home, and end up being laid off due to this pandemic. So then the wife is the one stepping up, then say, I will cook, I will bake cookies, okay? And then the husband the one delivering it, you know, and double as the DoorDash driver or Uber driver, you know. So, I mean, in this kind of situation, you need to be creative. Okay, and yeah, you can do this. In fact, I get 2 or 3 requests for Thomas, what do you think I should do? And I asked that lady, what do you want to do? What you can do, okay? Regardless what's the situation, let's do the brainstorming first. Okay, what do you think you can do? Thomas, I can cook, but I don't think I can cook well. I said, well, sell your stuff first, you know. So if you can sell it and then you get opinion, from there you improve it. But at least sell it first, you know. And oh, by the way, one of them actually doing very well, such that the husband changed from full-time working from home, end up with only part-time working from home because the husband needs to help her doing the meatball. So somebody actually come up with that fried meatball. So I think she mixes pork and beef meats, ground meat, and then kind of like you do it in certain ways. Of course, I don't know the ingredient, but I know it's like kind of like mixture between pork and beef. But if you sell it just as a meatball, it's actually quite available in the market. You know, what she did was she actually fried it, and it sells very, very well because this fried stuff, once she fried it, it can stay stay quite fresh with the vacuum. You vacuum the container, right? And she can send it. It can stay fresh for like 5 or 6 days. You know, so she get the order. She sent it out on Monday, and people from other states will receive it on Thursday or Friday, and then they can enjoy it during the weekend. So you see, it's actually a pretty good deal. She got so busy. She got so busy that she told me, Thomas, I sent out around 10,000 meatballs. I sent out around 10,000 meatballs, and she sold each meatball for 80 cents. Okay, so that 10,000 meatballs translates into $8,000. Okay, and her profit margin is approximately 50%. Not bad, honestly, especially during this pandemic. And she can stay home, and her husband actually help her. Okay. So, hey, by the way, don't underestimate the power of your wife. Your wife can step up and do you a big favor. Okay, don't look down on anybody. You may say just like it's just a fried meatball, Thomas. How many people would like that? Well, if you throw it to Facebook, you suddenly have millions of people looking at that, and the way they think is like fried meatball is something they can bring anywhere they want. Do you think so? Right? Okay. They don't have to sit on the table to enjoy it. Okay. Now, Thomas, then why that person don't do burger, for example? Well, burger is something you can get other place. The market is saturated, right? Offer them something new. Okay. Something so new that people will not say, oh, I don't like that thing, simply because they have never tried such thing. Right? Okay. Well, business ideas, right? Okay. Let me give you more problems, but this time I get it from textbook. Give me a second. This is from 4.3 in our textbook. Again, I don't think the number they use here are actual numbers. Okay, they say based on data from variety of sources. Okay, but the way I see, if you don't name your source, consider that hoax. Okay, so we use this as just hypothetical number. Can I ask you to do this problem? 1, 2, 3, 4, 5, 6. Let's say we do it in 7 minutes. Let me use no color. Okay, so this guy here is 337, 1,163, a total of 1,500. This one here, 345, 1,155. Okay, number 17. False positive. False positive is when somebody is tested positive while that person not having the disease. Oh, by the way, it is a fact that most of those people tested positive actually don't have it. So I'm sorry to tell you the truth that the number of people tested positive, the numbers that you see in practice, right, in our real life, that number supposed to be much less. Why? We have found some cases where that person only applied to be tested, but then not going into the clinic. But because that person already have appointment, the clinic then mark that person as positive, even though no testing was performed yet. Okay. That's they already found it out, or not to say that they already found some faulty result also. Okay, now so that's what we call false positive. When that person don't have the disease, but using this test, they found it to be positive. Okay, now that's what false positive means. Now in this case, how many people without hepatitis C? Without hepatitis C is 1,155. Am I recording this yet? Okay, and of those people not having hepatitis C, how many of them tested positive? 2 of them. Okay, 2 of them tested positive. So this is what we call false positive. False positive is when that person actually not having the disease, but that person tested positive. Okay, you can imagine if I take for example, another example of false positive is like when you give me a pregnancy test and it shows positive. You see, then you know if it shows positive, it must be false positive. Why? I'm a male. I cannot get pregnant, right? Okay. Yeah. One day maybe that's possible, but for now we don't have that case yet. Okay. Then in decimal, this will be 0.00173, and this is considered very rare. Why is this the case? Why is this case problematic for test subjects? Then that person may be unnecessarily quarantined. The worst part is that person may get the treatment, unnecessary treatment, harmful treatment that he or she not supposed to get. Now part number 18, false negative. What is false negative? False negative is when that person actually have the disease, however, the test shows negative. That's false negative. Okay, now then from here, how many people actually have hepatitis C? 345. Of those have hepatitis C, 10 of them shows negative. This is 0.02899 if I round to 5 decimal places. It is still considered rare, but from a medical point of view, this number is actually quite high. But by the way, I'm telling you that's my opinion. The fact that 2.899%, is it high or not? It's actually up for interpretation. Okay, for social science, of course, this is low. Okay, but the consequence of this is quite bad, such that we should consider this high, because what is the consequence? What would be an unfavorable consequence of this error, right? Well, imagine if somebody with hepatitis C tested negative. That person will think he or she doesn't have the disease and going around unintentionally spreading hepatitis C to a lot of other people, right? Now, this could be the case of what we call asymptomatic. Okay, even though this person get a test, right? Okay, But imagine if this person have hepatitis C and not showing any symptoms, okay? And this person don't want to take the test, okay? And this person say, I don't want to take the test because I'm asymptomatic anyway. I don't have any symptoms. So why should I spend money to get the test, right? And this person walk around, go shopping here and there, right? Okay, the following is my personal opinion. The following is my personal opinion about this pandemic. Especially at the beginning of this pandemic. I can show you my email that since the beginning, very beginning, I already said to my students from last semester, actually in the spring, that if I were you, I will not go out. I will shelter. Even before they told us to shelter, okay, before quote unquote the partial lockdown. I think in the beginning of the end of February, I already told my stat students. In fact, the first group of students I told was my ELAC college stat students in the spring. And I told them, if I were you, I will not go out, okay? Try to stay home. If you need to go out, like if you are working or you need to bring your children to school, wear mask, okay? Because even at that time, I already suspect that this pandemic is airborne. At that time, World Health Organization said that it's not airborne. In fact, they have the official statement that it is airborne at the beginning of this month, earlier this month. But in February, they say, no, it's not airborne. And a lot of excuse they gave at that time, you know. But I happened to do epidemic model in my undergrad as my final project. And I developed certain kind of modeling to do some prediction. And at the beginning of this pandemic, sometime around end of February, the beginning of March, my professor, who was my advisor on that my research 20-something years ago, he was very, you know what, let me show you. Let me show it to you. Let me show it to you. This don't need to be recorded. Okay, I continue. Number 19. Positive predictive value. So the probability somebody tested positive knowing that person have hepatitis C. Knowing that person have hepatitis C, with hepatitis C 345, the probability and the portion of those tested positive 335. That will be 0.97101. So this test is actually quite reliable. Number 20, probability of tested negative knowing that person don't have hepatitis C. Now this kind of statistic here, this kind of analysis of false positive, false negative, is actually necessary if the testing procedure is new, because we want to know if the test is reliable or not, right? If we already know that person has hepatitis C, what's the point of testing that person again, right? You see what I mean? But we need these people to test the testing procedure, to test the reliability of a procedure being used to test, okay? Especially if you already come up with a cheaper, faster test result, okay? Now then, how many people not having hepatitis C? 1155, and of those not having it, 1153 tested negative. So there will be 0.99827.
Professor, for number 19 and 20, I got like the notation switch, like so I put like hepatitis C and then the line and then positive for like number 19. Is that incorrect? Or like I just switched the positive and the hep C around. Number 19. And same with number 20.
Oh, I'm sorry. I didn't read it. I didn't read. My bad. I make mistake. I make mistake. For number 19, oh, thank you for pointing it out. I didn't read it correctly. Sorry. Find the probability that person have hepatitis C. You're right. Given that that person tested positive. So we see how many people tested positive. Thank you for pointing it out though. I make a mistake. That's a mistake. Okay, so that's not the question. I answered wrong question. Okay, so tested positive is 337. Okay, but the one actually have the hepatitis is 330. Is it what you were doing?
Yeah, so that's what I was doing for now.
Yeah, this is the correct one. Thank you. This is the correct one. 335 divided with 337. Okay, so this will be 0.99407. Thank you. I didn't read the question. I just assumed that because I read from the positive predictive value. Okay, I read from those two and I assumed this thing. I assumed these two things. But see, my assumption was wrong. I didn't read the question. My bad. Okay, and number 20, find the negative predictive value of the test. That is, if somebody, the probability that somebody don't have the hepatitis C, knowing that person is tested negative. That person tested negative, how many? 1163. 1163 and not having hepatitis and tested negative 1153. 1153 divided by 1163. That's 0.99140 in 5 decimal places. So in my opinion, it's actually pretty good. Yeah, in my opinion, it's actually pretty good. Now, however, is it okay right now?
Yeah, I think so.
Yeah, okay. Now, let me put more stories into this. For those companies that are doing this kind of test, they are aware that they may come up with false positive and false negative. They may come up with false positive and false negative. So with that kind of, with this kind of probability, they're supposed to put it in their test that if you are tested positive, then the probability is false positive is what? Probability if you are tested negative, the probability that it's false negative is what? Why? Because they need to anticipate lawsuit. You know why those companies, then they charge some money, and especially at the beginning of the if they come up with a new test and they sell it, at the beginning of the sale of those kind of tests, it's usually quite expensive because they need to cover the costs and try to get enough money in case they need to get, in case they get a lawsuit. Okay, imagine if they say, for example, if they say if you are tested positive, the fact that you don't have hepatitis C, but you are tested positive is this, right? And then these two people went to get a treatment, and it turns out that after treatment, they don't get better because it's actually not hepatitis C. Then these two people lose their lives, and then the family filed a lawsuit against this company. That would be millions of dollars, right? Okay, now where they get that millions of dollars? Of course, this company is doing this, working on medical field, not only to help people with hepatitis C, but also to help the scientists working behind this. And of course, as a company, they need to make money, right? Now, to anticipate those things from happening, okay, of course, they do research first, but there's still a chance that they try to prevent that from happening, but it still happened. So they need to prepare some money in case they get a lawsuit to pay to cover for the settlement. You see that? Okay. Now, I'm not teaching you to defend this kind of company.
Wow.
Okay. I'm not teaching you to go against this kind of company either. I'm teaching you their point of view. Okay. So if I'm not saying it just justify them to charge thousands of dollars for this kind of test, okay? But at least you know why they need to charge more than the cost of making that test, the cost of running the test. Why? Because there's a research that they need to fund to come up with such kind of procedure or that kind of test, okay? But again, I'm not agree with them 100% for charging too much. When like right now, if you are going for a COVID test on your own, you will need to pay approximately $200. You can get it for free, but the one that you get for free, you need to get in line, like for quite a long time. I heard. Okay, but if you and there's a chance for you to get that kind of test, the free one. You need to go to a place with a lot of people, and your chance of contracting the disease there is actually quite high. You know, so some people then choose to have their COVID test done at home, for example, right? Okay, and when they chose to have the test done at home, then of course somebody needs to come to your house and do the test for you, and that person has to be fully, not only fully protected. Okay, basically that person need to come in a suit that no contact between you and that nurse possible. Okay, basically that person need to come with what do you call that? Hazard suit, biohazard suit. You know, just because this is the guy. Imagine this nurse is going around testing people, right? Okay, so who knows that if he's not protected, he's not wearing that biohazard suit, he could be the one bring the disease into my family, into my household, right? Okay, so with that kind of situation, you need a nurse, and this nurse has to drive around, and this nurse has to wear a biohazard suit. Of course, not to say the test itself, it will cost something, right? Okay, now will $200 bill will be reasonable? Maybe, maybe not. It depends on how much you are willing to take the test. Now, when people ask me, Thomas, did you test yet? I say, no, I don't test yet. I don't get tested yet. Why? I don't think I need. I'm not going out anyway, right? So either I already have it and I'm asymptomatic, therefore I'm not going around, okay? Or I don't have it yet, okay? And I don't want to get it, therefore I don't go out. So either way, doesn't matter. I don't need it now. When will you get it, Thomas? When I go out in public later on. For example, one day I need to go back to Indonesia. I plan to go back to Indonesia this December to visit my parents. I supposed to visit them this summer, but because of they closed Indonesia, I hope in this December they open it already, and then I can go visit them, just to make them happy that I still care about them. Okay, but then if I need to go, I need to make sure that I'm clean, not active. Okay, when I say clean, in the sense that I don't have the active virus in my body that I'm spreading the virus around. Okay, so a lot of thought being put into this though. Now I've just talked from statistic and mathematics and the disease point of view. I have not talked about the economic consequence of having lockdown, you know, which is not really my field. Okay, well, this is the parts for our conditional probability. Now the theory. What if no Venn diagram nor contingency table given. Notice that we did all those conditional probability above without any formulas. We just look at the Venn diagram, okay? Contingency table, right? Venn diagram again, contingency table from our textbook. By the way, our textbook seems like not providing Venn diagram case, okay? But I provided to you. We have those examples, example 3 and example 1, right? Okay, but what if we have neither one of them? Then we use formula. Then we use formula. Now the formula for probability, conditional probability is the following. Probability of A given B is equal to probability of D intersection over the probability of the condition. Now notice that the condition always on the denominator. In fact, notice that the denominator here is not the probability, but it's the number of elements, in this case, of the condition. Okay, so in the past, prior to this formula, we actually have this probability being computed this way. Number of elements of the intersection divided by number of elements in the condition. That's how we did it earlier, right? Okay, but the thing is, what if we are not given the number of elements? What if we don't have this, we don't have this? Then we use the probability. But Thomas, what justifies this? The following is not a good justification. Theoretically, it's not correct. Okay, but to make you feel it, imagine if I divide this by the number of elements in the sample space. Divide this by the number of elements in the sample space. Then you realize that the denominator here is basically the probability of getting B. And the numerator here is the probability of getting the intersection. Okay? Now, how do we use this formula if we don't have Venn diagram or contingency table provided? But Thomas, what if I use this formula anyway? Even when I have Venn diagram, even if I have contingency table, then you still get the right answer. It's just like you're working too hard. Okay, let's see, under what situation we use this. Suppose, for example, probability of A equals to 0.8, probability of B is 0.7, probability of D intersection is, let's say, 0.5. No, I cannot do 0.5, 0.6. Then what is the probability of getting A given it is in B? Then according to the formula, let me write down the formula: probability of A intersection B over probability of B. Then plugging numbers, that's 0.6 over 0.7. In decimal, in fraction it is 6 over 7. In decimal, that's 0.85714. Probability of B given A will be, what will probability of B given A? That's probability of D intersection over the probability of A. That is 0.6 over 0.8. That's 3/4 in fraction, or in decimal 0.75. Okay, now I'm about to give you a break, the long break. But together with the long break, I would like you to do this problem. Suppose probability of the union is 0.9. Probability of A is 0.7. Probability of B is 0.5. Then part A, find the probability of the intersection. I hope you know how to do this already at this point. I think we actually did this kind of problem earlier in our review. Right? Okay, we get probability of A, probability of B, and probability of the union, find the intersection, right? Okay, so I should assume that you can do that. Now, then once you get probability of the intersection, then you can find the probability of A given B. And probability of B given A. Okay, now right now it's 12 o'clock. We come back at 12:25 with this problem already done. Okay, probability of the intersection. I need to use inclusion exclusion formula. Let me write down the formula first. The probability of the union equals to probability of A plus probability of B minus probability of the intersection. This is 0.9 equals to, I'm sorry, yeah, the union equals to 0.7 plus 0.5 minus probability of D intersection. 0.9 equals to 1.2 minus the probability of D intersection. So probability of D intersection equals to 1.2 minus 0.9, that's 0.3. Now then we use that result for the conditional probability in part B. Probability of A given B is probability of D intersection, which we got from part A, over probability of the condition, which is probability of B. That's 0.3 over 0.5, we get 0.6. Lastly, probability of B given A is probability of B intersection over probability of A. That's 0.3 over 0.7, that's 3 over 7. In decimal, that should be 0.42857. Are you okay with this? Good. Now, let's go on. Let's go on. Now, what I gave you here, these two examples here, not in your book, but I think these two examples here tends to be on the easy side. Okay, the following turns out to be not as easy if you go to our math lab. If you ask for help from our tutors in the math lab, there's a chance they have never been exposed to this kind of question. Suppose I give you a probability of A equals to 0.4, probability of B given A equals to, well, probability of A given B. A given B is 0.7, then probability of B given A is, let's say, 0.6. Let me make sure I get it right first. Yeah, I think it should be okay. It should be okay. Now then, the first question is, what's the probability of the intersection? In fact, of the next couple of questions we have here, part A is actually the hardest one. Why this question is hard? Because we don't have any formula explicitly to find the intersection except the one we learned from inclusion-exclusion formula, like the one we had earlier, right? We use that to solve for this. But the problem is, even in this formula, we know the union and the A and the probability of B, right? Okay, we have those. While in our formula, we have, in the question we have here, we don't have any one of those. Actually, we only have probability of A. So what should we do? The hint is actually looking at the formulas. Probability of A given B, the formula is probability of D intersection over probability of B. The one in question is this. The one we have, only this, right? But we don't have this thing. We don't have that thing. So we cannot use this formula. On the other hand, probability of D given A, that's probability of D intersection, which is in question, over probability of A, which we already know, which is given. So this is the one in question. These are the one we know. So we should use this second formula. Now the thing is, to come up with this kind of analysis, you need to have certain level of maturity in math. And of course, you need to memorize the formula. You see what I mean? Okay. Of course, I don't want to throw this question in your test too, without warning your head. Okay, but expect this kind of question in my test 2, not test 1. So this is what I will do. I will start with probability of B given A equals to probability of D intersection over probability of A, and then I plug in numbers. 0.6 equals to probability of D intersection over 0.4. Multiply both sides by 0.4. That's probability of the intersection, which is 0.24. Okay, now then we go on to part B. What is the probability of B? Now notice that we now have known this part. We also already know this, that's given in the question. We can ask this now. We can ask this now. What is the probability of B? That's the one in question now. Okay, that's the one in question. Then that's what I do next. Probability of A given B equals to probability of D intersection over probability of B. Probability of A given B is 0.7. Probability intersection we get earlier 0.3 over probability of B. Multiply both sides by probability of B. Then probability of B is 0.3 over 0.7. That's 3 over 7, which is 0.42857.
Professor, did
Yes.
you get, were we supposed to use 0.24 for probability of 8?
Ah, my bad. Intersection. Yeah, why did I use 0.3 there? Thank you. Oh, I'm glad that's at least now I know somebody pay attention. My mistake. So you're right. Where did I get that 0.3 earlier? It's from the previous question, I guess, huh? 0.24. So this is 0.24 divided by 0.7. That's 0.34286. Is it okay now?
Yeah, I got the same thing.
Okay, now then, notice that now we already have probability of A, probability of B, and probability of the intersection. So automatically, then I can ask further. Let me use this first. I can ask what's the probability of the union, right? Yeah, I can ask the probability of the union. Now, probability of the union, I think that's something we can easily do because we already have probability of A, probability of B, and probability of the intersection. Now, in your test tool later on, I will write the question this way. Basically, I scaffold that. Scaffold means I will get you, I ask you this first, and then this first, and then this, and then this. In my final, however, I may not ask this anymore. I don't ask this. I just go ahead with part C right away. Unfortunately, even though I go ahead with part C, you still need to do part A and part B on your own. So here's the thing. Do you notice that some students like to ask the following question before the test? Thomas, how many questions would you give in the test? And then I ask them, how many do you want? Right? I have three questions in mind. Right? I have 3 questions in mind, A, B, C. Can we have only 1 question? Fine. So I just get rid of A and B. I ask you C right away. But in reality, when you do this kind of quiz or this kind of test, you still need to do A and B. I just didn't explicitly ask you. But at the same time, though, if I don't guide you with A and B, I don't think you have any way, any idea to get this without me scaffold that for you first. You see what I mean? You know what I mean by scaffolding? Like the work for the later question relies on the work you have done in earlier questions. Okay, you scaffold that. You see? Okay, so if let's say I have 4 questions here, I kind of guide you, this is A, this is B, this is C, this is D. And you say, can we have only 1 question, Thomas? Okay, I give you a question part D. But for you to work on that, you still need to do A, B, C anyway. So what's the point of you asking me how many questions? Right? No need. Okay, I understand what you mean. I understand what you mean. Trust me. From my old tests and from what I have done in this class so far, I went over the previous test earlier, right? I hope you have faith in me that the time I give you is enough. Okay? So, and it's independent of how many questions I ask you. In fact, the more questions, the better, because with more questions, I basically guide you through those questions to answer more difficult topics. Okay. Now, then this one, I think you can just do it yourself. This is 0.4 plus, what's that, 0.3 something, 34286. 0.34286 minus 0.24. 0.50286. Is it right? No. That's 0.4. Oh yeah, that's right, 0.5. Now the thing is, this last example is actually not in your textbook. This last example is not in your textbook. They did teach that implicitly, but they don't really have this kind of question in their exercise. While this kind of question is the one being asked when you do some probability. Once you, for example, if you go to USC, right, you transfer to USC, when they do their probability, they do this kind of things. Okay, supposedly, unless they get even easier teacher right now. Now, let me go on a little bit further. This time is actually worse. How about the probability of complement of A and B? We don't have any formula for this. Let's develop that. Let's develop that. Okay? So you take a look on the Venn diagram. Let's say this is A and this is B. Now, outside of A but inside of B, outside of A and inside of B refers to this region. Outside of A but inside of B refers to this region. Are you with me? Can you imagine that? Right? Outside of A, inside of B. Now the thing is, how do we come up with the formula for this? What we can do is, you grab the whole B first. You grab the whole B. You grab the whole B, and then subtract the intersection out. We get the whole B, and then subtract the intersection out. So we can say this is equals to probability of B minus probability of D intersection. Does it make sense? There's actually another way though. There's actually another way. Another way is I grab the union, which I already have in part C. I grab the union. The union is the glasses. This is the union, right? You grab the union and then you take A out. You cut that A out. Get the union of A and B, union of A and B, and then you subtract by the probability of A. Or probability of the union minus probability of A. Now, either one of these formula will give you the same result. Either one of these formula will give you the same result. Okay, now, I want you to study for your test one, right? Okay, I want you to study for your test one. Next week, I will go on with counting technique, and that section is actually heavy. That section is very heavy. Now, the last part of 4.3 is actually not in the curriculum, a Bayes theorem, but I will teach that after your test one. So 2 weeks later, you have your test one for 2 hours, right? After test one, then I will go over Bayes theorem. Okay? Now, what I want to do now is 4.4. 4.4 counting techniques. Counting techniques, and this section is a very long section. This section is very long section. It usually takes me like approximately 4 hours to explain it in full. Of course, I cannot finish it today, but at least I can teach you now the calculator part. Now, I see that there are 12 people here right now, 13 with me. Is there any one of you don't have your TI-84 yet? Okay, maybe I ask this. How many of you already have your TI-84? Let me do a poll. Edit. I did sign up. Oh, no, I don't. No, I don't do poll. Sorry. How many of you don't have your calculator yet? Okay, one person. Do you have any idea when will you get it? Will you be able to get it in this week? Oh. Oh. For those who don't have calculator yet, do you remember the Facebook group that I showed you? I think on the first day of class. Okay, try to be a member of that group and then ask if anybody have calculator that they can sell for you. Okay, if you try to buy it online, I know I will not buy it online. At this point, I will actually go to Staples or Office Depot to buy it. You can also go to eBay to buy it, but you know, if somebody need to ship it to you, it will take at least 1 week, right? Especially if it is from other state. Now, why I suggest you to go to Facebook group first at ELAC College 1. So you Google ELAC book sale or ELAC College book or ELAC College something, and then you post your request there. Okay, why? Because if somebody is selling it there, very likely that person live in surrounding of ELAC College, hopefully. Okay, and then you can just drive to get the calculator from that person, and hopefully you can get it cheap. Like, I think $50 is the minimum you should expect. Okay, if that person is really nice, you can get it for 40, but get ready with $80. Okay. Well, anyway, I hope you get it as soon as possible so that you can start watching. Go back to this video, watching on how you should do the punching, how to punch your calculator. Okay. Must I have the physical one, or may I only install it on my PC? Actually, temporarily, you can just install it on your PC. You know, temporarily. In long run, I don't think that would be good though. Maybe you download it on your PC first. Okay, install it on your PC. Right. Let's see. I believe I already showed you how to get that online, right? The one you can get the trial period. I think you get two. How many weeks? 2 months period, I think. Okay, download it first and see how much you get. You feel comfortable with that. I don't mind you to get the online one. If you can get it for free, the trial one, go for it. Okay. The thing is, if you start this week, then on your final is actually more than 2 months from now. You know, so what you can do is like you uninstall it and then you install it again and use somebody else's email, or I mean, you get another email. You see what I mean? Okay. Yeah, so it's up to you. It's up to you. It's up to you. What I want is like if you can save your money as much as possible, then go for it. What I'm afraid is like when I teach online, for example, and then you still need to use your online calculator, which implies, I think that implies you need to have your computer or at least a laptop in front of you. You cannot use your smartphone. You see? Okay. I mean, you think about it. Okay. I don't mind. I don't mind if you use the emulator. Now, counting techniques. I will teach you right now only how to use calculator. Okay, only how to use calculator. There are 3 things that I need to teach you. They are not counting techniques, but more into notation. Notation. First one, factorial. N factorial means n times n minus 1 times n minus 2 all the way down to 3 times 2 times 1. And you start at 1. So for example, if we have 4 factorial, it means 4 times 3 times 2 times 1, which is 24. 6 factorial is start from 6 and you keep on multiplying down to 1. Okay, I think this is 720. Now the thing is, once it gets larger, it's harder to compute. That's 12 times 11 times 10, all the way to 3 to 2 to 1. Even if you use your calculator, it will be too much to punch. Okay, so I will teach you how to use calculator. And the way you use your calculator will be as the following. Okay, the factorial notation, the factorial can be seen at math, PRB, and there's an exclamation mark. Okay, so on our calculator, it's actually located here. You go to math, move the cursor. You see up here, it's math, right? And then you move the cursor to PRB. Now the 4th option is exclamation mark. Okay, now so how do I punch, for example, how do I punch 12 factorial? The calculator work will be, you punch the 12 first, and then you go to math, PRB, exclamation mark, and then enter. Now, if you already have your calculator, try it. Let me show you how I do it. 12, and then math, PRB, exclamation mark, enter. That will give you 12 factorial, but not the result yet. You press enter again, you will get the result. Okay, so after that enter, you press another enter here. Then you will get, what's that? 479 million. So 12 factorial is 479 million. And then 1,600. Is it okay? Now, let me make sure you get it. Let me ask you to get 10 factorial. Let me ask you to get, let's say, 8 factorial using your calculator. Do it, please. 10 and then math, PRD, exclamation mark, enter, that gives me 10 factorial. Another enter gives me the result. 3,628,800. 3,628,800. How about 8 factorial? 8 math, PRD, exclamation mark, enter, give me 8 factorial. Another enter, give me the result. 40,300. 40,300. Any questions so far? Okay, I assume no. Okay, next. Permutation. Second one is permutation. The notation is, this one is a little bit confusing at first, but it's actually not too hard. Notation is N, P, R, where the N and R are subscript. Which means it's smaller and lower. Okay, so for example, if I type it, let me see if I can enlarge this. Yeah, if I type it, it will be as the following: N, P, R, but the N is a subscript. The R also subscript. You see what I mean? So it's supposed to look like that. The size of the N and the size of the R should be smaller and lower. Okay, that's if we write it. Now, the thing is, our calculator, when you see our calculator later on, they do not do the subscript. So on your calculator, it will look like this. That's on your calculator. But that's because your calculator tried to save some space by not doing the subscript. But when you write it down, you're supposed to do the subscript. The P, capital P, is regular size. The N and R is smaller and written lower. Okay? Oops. Now, what does this mean? This means N factorial over N minus R factorial. Thomas, that looks complicated. I know, don't worry. It's just the meaning. Okay, suppose for example, I have 6 permutes 4. 6 permutes 4. What does it mean? According to the formula, that will be 6 factorial over 6 minus 4 factorial, which is 6 factorial over 2 factorial. This will be 6 times 5 times 4 times 3 times 2 times 1 over 2 factorial is 2 times 1. Notice that this guy cancelled, right? This guy's cancelled. And you will see the following phenomena. You will see the following phenomena. The 6 here is the number you start with. The 4 here is the number of factors you have, starting from that 6. So, with that said, for example, if I have 10P3, what does it mean? without doing all those work. It means I start from 10, okay, and then I get 3 factors, 10 times 9 times 8 equals to 720. The 10 coming from here, that's the 10. The 3 means 3 factors. Okay. So suppose I give you what is 15 permute 2. 15 permute 2 means you start from 15 and you just need 2 factors, 15 times 14. That's 110. Thomas, can we just use calculator? Yes, you can. You can just use calculator. Okay, but sometimes I think when the number is small, just use the formula a bit. Okay, use your instinct a bit. Okay, so how do we punch NPR? Let's say, for example, if I want to use calculator, how do I punch that 10 permute 3? We will punch 10 first, okay, and then we will punch NPR. And then we press enter. And then we press 3. And then after that, we press enter again. Now, where's the NPR, Thomas? The NPR is located in the same section with exclamation mark, the factorial. That was in math, PRB, NPR. Let's take a look. What's that? So 10, right? And then math, PRB, NPR. You see? And the third one later on is NCR. So NPR, NCR, exclamation mark in the same group. And then 3. Boom. You see that 720? Okay. Let me check the last one. How about 50? Oh, how about 15 permutation 2? 15 math, NPR, PRB, NPR, 2, enter. Actually, after I typed the NPR, I don't need this enter. Sorry. I don't need this enter. I can just do 3 and enter right away. Okay. Now you practice. How about if I ask you 17P4? Can you try that? 1 minute. This will be, let's see. So 17 math, PRB, NPR. Oh yeah, I need to press enter. And then 4, enter. Sorry, I really thought earlier I did. Basically, you press enter to get out from that NPR. So this will be 57,100 points. 57,100 points. Are you okay? Okay, let me assume so. The third one, oops. The third one is combination. You don't need it now. So when you study for your test one, you don't need it. Next week, we will need it. But of course, next week, I will remind you again how to use it. Okay, but I hope from here you see that we will need your TI 83 or 84 by next week. Okay, now combination, the notation is, NCR, where the N and the R are subscript, smaller and lower. Okay, now you know the position of NCR, right, on your calculator. Can you assume similarity with permutation and compute this? For example, let me ask you to compute 10 combination 4. And then 12 combination 7. And how about 20 combination 18? Can you try that with your calculator? I forgot to record it. Well, anyway, I forgot to record earlier, but you try to figure out. Okay, it's very similar to NPR, except that you use that NCR option instead. Now, what NCR means by formula, that's n factorial over r factorial by n minus r factorial. So you see this portion here is basically the permutation portion. Now, in case you are interested to learn to do it by hand manually, especially when the number is small, like n choose 2, n choose 3, n choose 1, n choose 0, okay? Let's say I have 5C2. What does it mean? This means 5 factorial over 2 factorial, 5 minus 2 factorial. That's 5 times 4 times 3 times 2 times 1 over 2 factorial 2 times 1, 3 factorial 5, 3 to 1. Now, just like what you saw in permutation, this part here cancels, right? Now, the blue part here is 5p2 divided by 2 factorial. I still don't see pattern, Thomas. Don't worry. You need to chew it at home. Okay, you may watch this part again later on, watch this lecture video again. But suppose, for example, I have another example. If I want to do it by hand without calculator, suppose if I have 20 combination 3. What does it mean? Do the permutation on the numerator. On the numerator, do the permutation. 20 times 19 times 18. That's the permutation part. Divide it by 3 factorial at the bottom. 3 times 2 times 1. That's what it means. Okay? That's what it means. So I think this is 104. Maybe, I don't know. Let's see. Let me use my calculator to confirm. YE, math, PRB, NCR. Oh, 1,140. 1,140. Now, I assume most of you will prefer to use calculator, but if you took calculus 2, for example, it will be nice if you know how to do it by hand. Okay, it will be nice if you know how to do it by hand. Now, you will see, therefore, for example, NC1, that will be just N. Why? Because NP1 is N over 1 factorial. That's N. Right? Okay, so 500C1 is 500. On the other hand, NC0 is 1. Okay, now your suggested homework from 4.3, will be from number 1 to number 23. From 4.4, I look at the book, there's no problems that is in line with what we want to do here. Okay, but at least I have a notes for you to prepare for next week when we do 4.4. I think next week we can only cover 4.4. I don't think I can do more than that. Yeah, I don't think I can do more than 4.4 next week. Yeah, basically I finished 4.4. That should be what we have for that day. But at the same time though, it means I will go quite deep into that section, maybe more than what our textbook provides. Okay, this is where I will stop. See you next week. And I have one person, I remember, have a question.